Here's some sample programs in Matlab showing off some trig functions. Here we have r equals 1, x is our cosine theta, y is our sine theta, and this plots as the angle goes around, x versus y, cosine theta versus sine theta. Notice that the result is a circle, it spins counterclockwise. If instead you let r be cosine of theta, then what you get is, in green, that's what we had before. Sine versus cosine is the unit circle. If r is cosine theta, here for theta is bigger than 180, it's negative. Theta is positive. And then r is negative. R is positive. R equals cosine theta plus the circle going from the origin to plus 1. R is the absolute value of cosine theta. You get a circle to the right, and when cosine theta is negative, the absolute value is positive, still have a positive radius. I get two circles. R equals cosine squared theta gives a figure 8 pattern. When cosine theta is negative, r squared is still positive. When cosine theta is positive, r squared is positive, and I get the 2 halves, or angles between minus 90 and plus 90, positive, 90 and 180, and 270 is positive. Finally, the last problem on the homework, if r equals cosine 4 theta, I get this. For cosine theta positive, I get this part of the curve. When it's away from the red line, cosine theta is negative. Finally, just for fun, it's not on the homework, but it makes a pretty figure. If I do cosine of 2 theta squared, I get this, a little dogwood flower. For cosine theta positive, I get cosine squared. Cosine is negative, cosine squared is still positive. Just kind of some of the neat functions you can build using polar coordinates, basically trig functions in Matlab.